Hello, everyone. Welcome to the Fundamentals 2. Okay, last class we fundamentals we, we stopped in certain place. We are talking about physical and chemical changes. Okay, physical and chemical changes. So, what are the physical and chemical changes? So, physical means melting, like melting, boiling. These kind of phase transition are called physical changes. Okay, chemical changes means a complete transition. Like, for example, if you take water molecule and then you dissociate into hydrogen and oxygen, this is a chemical reaction, because what happened in the water is you broke the bond between hydrogen and oxygen here, and then you made two hydrogen molecules, and then you made two oxygen molecules. You have to balance this reaction anyway, but simply saying you have to break the bonds. Breaking bonds happen in chemical reaction. This is very, very important understanding. But in physical, it doesn't happen. If you take water from solid, you just melt to liquid. Okay, due to temperature changes, it just melts from solid to liquid. No bonds are broken. No bonds are broken. Okay, this is very important. But changes are also visible, right? So you have to see between, like, if you take just you take paper, okay, you take a paper and then you rip the paper. You take a paper and then you rip it off. So this is just a physical change. But if you burn a paper, so the paper is going to burn in oxygen, and then it's going to form carbon dioxide and impurities, right? So this is a chemical reaction. So in chemical reaction, the changes are visible. So like you might see some color changes. You will see color changes happening. You will see temperature changes. The heat might increase or it might decrease. So the heat might get released, or the heat might be absorbed. Okay, there might be gas evolution. So you will see some bubbling reactions, or a precipitation reactions. That precipitation means a solid formation can be seen. So these are all identification for chemical reactions. But in physical reactions is very simple. Okay, it looks, there is no bonds are broken, no phenomenal changes are seen. Now, in the properties, we classify the properties into two of them. One, we call them the intensive property. One is called as intensive properties, and another one is called as extensive property. What is intensive and extensive? Intensive means the amount of matter the amount will not affect the property. The amount will not affect the property. Okay, so let's take honey. If you take honey and you take 1 gram or 100 gram, the density is going to be same. The density remains same. But the extensive property, if you call mass or volume, length, shape, these things, if you add the amounts, if you add more amount, the length is going to increase, the shape is going to increase, or volume is going to increase, the mass is going to increase. The amount affects this property. Okay, the amount affects this property. Okay, so the density is not the only example. If you have conductivity, malleability, ductility, all these things are intensive properties, because it does not matter. If you take an iron, whether you take a small piece or a very big piece, the conductivity is going to be the same thing. The malleability or the conductivity, the amount the strength you need to bend or to squeeze is going to be the same. So basically, it is not going to get affected by the real properties. The intensive property will not affect them. Okay. So if you want to test the chemical properties, you have to take reactions. You have to subject any substance. You take a substance and then you react the substance with acid, a base, you throw it in water, and you You keep it in air for some time. Okay, you soak some chemicals to see what happens, right? You heat and see what happens. These are the things that you can see, that how they interact, how they react will tell you uh, whether the substance have chemical reactivity. So that can easily tell us what this is. Now, coming to the next part of this section, the fundamentals, is understanding accuracy and precision. This is a second set of topic that I believe it's very important from learning chemistry. So what is accuracy? So you have accuracy means if I have asked you to throw a dot on a certain place, let's say this is NJ. So I ask you to throw a dot on this. But you threw, instead of New Jersey, you threw, let's say this is Boston, you threw here. This is considered as a precise value. It is a close value. Okay, this is a precise value. This is the accurate value. This is what we want. Okay, this is a precise value. But let's say the dot you threw landed here. Somewhere here in Florida. This is both inaccurate and not even precise, right? So accuracy means the correct value. Okay, so if you want, if you want to get 100 in score, 100 is the maximum score. This is the accurate value. But if people get different values, let's say if they get 97, 98, or 94, or these called precise values. Okay, so we should understand this precision versus accuracy. Okay, so very clear understanding should be there. So because this helps you to understand significant figures very well. Now, we use commonly in lab, we use two things. One is called as the percent error. How to calculate percent error? The percent error can be calculated using accepted value, right, minus experimental value divided by the accepted value. I'm going to write AV and EV from now on, okay, times 100. Let's say the accepted value for the test, we have to get 100 out of 100. What you got is 80. The accepted value is again 100. And if you get another multiplied by 100, what is the error? The error is only 20%. So this is very simple. Okay, so we are just using, this is the value that you got, right? The experimental value. The second one is to understand the percent yield. Percent error is different from percent yield. Percent yield means how much you got when you make a reaction, right? Or the amount that you really got, right? This is experimental value divided by the overall value times 100. For the test, the overall value is 100. This is what you should supposed to get. But what you got, experimental value is 80. Multiplied by 100 is once again 80%. So what you got is only 80%. Right? This can vary. This is not going to be 100. Let's say that the overall test score is going to be 40, and you got a 35, and you have to multiply by 100 to get the final value. So these are very important we use in chemistry. Okay, so you should be aware of these fundamental concepts. The next one is using the SI and the metric system. In the SI and metric system, we use physical quantities. Okay, we are going to use only the common physical quantities. Okay, the first quantities that's related only to chemistry. We are not going to jump from all the physical quantities. Okay, and then there is a unit for this, and there is a specific symbol also for this. Let's take if you take mass. Mass. So the unit for the mass is kilogram. So you have to change everything into kilogram just to make sure everybody follows a certain standard. So the symbol is kilogram, kg. For length, this meter. So meter. For time, this is second. For temperature, it is Kelvin. So these are the major ones that we encounter during chemistry classes. Okay, we are not going to do anything beyond this. Okay, and the most important conversions are very important. So the conversions, everything goes by in terms of all multiples of 1,000. Okay, it's very easy to remember all multiples of 10 to the power of 3 or 1,000. So you have to remember this all the time. Okay, 1 kilogram. 1 kilogram is 1,000 gram. 1 gram is 1,000 milligram. And 1 milligram is 1,000 microgram. This is a symbol called micro. Okay. The same thing, 1 kiloliters is equal to 1,000 liters. 1 liter is equal to 1,000 milliliters. 1 milliliter is equal to 1,000 microliters. Okay, so you should always use what is called as dimensional analysis to solve this. Okay, dimensional analysis is a separate topic. I will go over this, okay, in detail. Okay, so this is very important. Excuse me. This is very important to go over to calculate. When you do conversions, you have to use dimensionals that to make that you get the correct answer. Okay, that's very important.